Okay, let's dive into this explainer. Welcome. Today we're jumping right into the incredibly high-stakes, multi-billion-dollar world of military tech innovation. We're going to look at how the US government actually tries to engineer the impossible. Turning actual science fiction concepts into battlefield reality. But maybe even more importantly, we're going to examine the massive bureaucratic hurdles that threaten to just completely stop these revolutionary advancements dead in their tracks.
To really grasp the scale of what we're talking about here, just picture this. The Department of Defense is actively developing futuristic systems to defeat modern threats, things like drone swarms and incoming missiles, literally at the speed of light. What we're talking about isn't some scene from a sci-fi blockbuster. It's a real-world concept of directed energy weapons. They're using high-energy lasers and high-power microwaves to defend bases. It's a completely new paradigm in defense.
So what are these exactly? Directed energy weapons, or DEWs, use concentrated electromagnetic energy to deliver destructive or sometimes just disruptive effects. And why this absolutely matters, especially to the defense budget, is that they offer a significantly lower per-use cost compared to traditional kinetic weapons, like your standard interceptor missiles. Because think about it, you don't really want to be firing a $1 million missile to take out a $1,000 drone, right? Instead, you're firing concentrated light. It's a transformative shift designed to maintain a tactical advantage without breaking the bank on traditional ammo.
And the military is taking this very, very seriously. The DoD spends an estimated $1 billion every single year just pursuing these directed energy technologies. But that raises a pretty fascinating question. How exactly does the government invent and develop something this incredibly cutting edge? To answer that, we've got to look at the engine behind America's military breakthroughs.
Section 1. The DARPA Innovation Model, Engineering the Impossible. Let's zoom out from the flashy weapons for a second. How does the government actually invent things like this? Well, it comes down to the Defense Advanced Research Projects Agency, better known as DARPA. To really understand how we get this tech, let's trace how DARPA evolved. It was actually born out of technological surprise back in 1958. The Soviet Union launched the Sputnik satellite, and man, that sent an absolute shockwave through the U.S. defense establishment. So DARPA was created to ensure the U.S. would be the initiator rather than the victim of future technological surprises. And since then, their track record is just staggering. In the 70s, they pushed forward stealth tech and precision missiles. By the 90s, their research gave us the foundations of the internet and GPS. And today, they're pioneering crazy stuff like neurotechnology and advanced autonomous systems.
So how does DARPA consistently innovate at this level? It relies on a flat organization built on 4 main pillars. First, extreme trust and autonomy for its program managers. Now what's really interesting about this slide is the second point, a strict, limited tenure. Managers only stay for 3 to 5 years. This intentionally prevents career building and really infuses the agency with urgency. You get in, you build something incredible, and you leave. The third pillar is a massive sense of mission. And fourth is a deep, baked-in tolerance for extreme risk.
And I mean extreme risk. DARPA will actually reject projects just for not being ambitious enough. They literally view failure as just the cost of doing transformative research. Take the 1970s, for example. They funded a quote-unquote mechanical elephant designed to transport troops through the jungles of Vietnam. A former director later famously called it a damn fool project and killed it off. Or fast forward to the Falcon hypersonic vehicle in 2011. It spectacularly exploded 9 minutes into a test flight when its outer shell just peeled right off. But to DARPA, hey, if you aren't failing occasionally, you simply aren't pushing the boundaries of physics hard enough.
Section 2. Funding the future, where the money goes. Now, let's shift our focus to how this agency actually distributes its massive budget to catalyze these technological breakthroughs. Because inventing the future, well, it isn't cheap. You might actually assume DARPA has massive, secret underground laboratories of its own, but they don't directly operate any research labs. Instead, they act more like a catalyst. As we can see here, nearly 70% of DARPA's research and development obligations go straight to agile industry partners. Another 13.6% goes to universities and colleges. They rely heavily on external experts, using special contracting flexibilities to work with startups and commercial companies who might normally totally avoid the red tape of government business.
When we break down the character of their work, it's heavily weighted toward creating foundational knowledge. Looking at these figures, the bulk of their funding goes into applied research and advanced technology development. This makes up what the DoD calls the crucial science and technology budget. DARPA is essentially doing the early-stage proof of principle, taking ideas from impossible to implausible to surprisingly possible.
And the scale of this investment is just massive.
To put it in perspective, the president's fiscal year 2018 budget request proposed a staggering $3.17 billion for DARPA. That represents nearly a quarter of the entire defense science and technology budget. So the government is absolutely all in on funding these high-risk, high-reward research initiatives.
Section 3. The Valley of Death, the bureaucratic hurdle. And here is where we hit the narrative twist of our explainer. Inventing the incredible sci-fi technology at DARPA? That's actually only half the battle. So the crucial point is that the real hurdle is a massive culture clash within the military itself. On one side, you have the development community, folks like DARPA. They're agile, they create these bleeding-edge prototypes, and they totally accept that a technology might not be fully mature yet. But on the other side, you have the traditional acquisition community. These are the people who actually buy and deploy equipment to soldiers, and they are highly risk-averse, incredibly traditional, and demand absolute technology maturity before they're willing to sign a check. This severe disconnect creates what is notoriously known in defense circles as the Valley of Death. This is the perilous gap where amazing, working prototypes, exactly like those directed energy weapons we saw earlier, often just stall out and die. The developers think the tech is ready, but the acquirers think it's way too risky, so the technology just sits there. It fails to transition into an active military acquisition program, which means all that time, money, and brilliant engineering never actually makes it to the battlefield.
Section 4. Bridging the gap. Will we actually use DUs? Let's take a look at how the different military branches are currently handling this exact transition crisis, specifically for directed energy weapons.
We're actually watching this crisis play out in real time. We have these amazing laser prototypes, but will we use them? The Government Accountability Office, or GAO, took a hard look at this. They found that while the Army seems to be bridging the gap, they've developed a detailed plan with clear schedules and stakeholder roles. The Navy and the Air Force are severely struggling. The Navy has fielded several really cool laser prototypes, but currently has absolutely zero documented transition agreements to get them into production. And the Air Force? They haven't even prioritized establishing transition partners yet. And this brilliantly illustrates a stark warning from the GAO. As they put it, without these transition planning steps, the Navy and Air Force risk developing directed energy weapons that may be misaligned with operational needs. Basically, without a committed partner in the acquisition community to catch the technology as it comes out of the lab, we are risking pouring billions of dollars into sci-fi weapons that the military simply can't or won't deploy. Which leaves us with this final thought to ponder. The DARPA model proves that we have absolutely mastered the art of inventing the impossible, right? We know how to take extreme risks and build the future. But the Valley of Death shows us that our greatest vulnerability might not actually be a lack of imagination. It might be a surplus of red tape. So can we master our own bureaucracy fast enough to actually deploy the technologies that will define the future of global security? Think about that, and I'll catch you in the next explainer.